graders, happy Friday. We're going to do a short quiz review before your mini quiz today. Everything we deal with on this video will be on your quiz. So this is basically your cheat sheet. Alright, topic number 1. Is it a function? Alright, so remember, a function is a relation where every input, every x value, gets matched to exactly one output. So every input has exactly one output. Alright, now you may get a set of points like 2, 6, 4, 9, and 2, 12. Is that a function? You look at the x values, the inputs. Do any of them repeat? 2, 4, 2. Ooh, they do repeat. So we have 2, which gets mapped to 6. 2 also gets mapped to 12. So this is not a function. No, not a function. It's not a one-to-one mapping, as we like to call it in math. Alright, 2 has 2 outputs. Alright, you may also be asked if a graph represents a function. So we have a graph here on the right, looks like an S. Alright, now we use the vertical line test to determine whether that graph represents a function, whether it has a one-to-one mapping. Alright, can I draw a vertical line anywhere that passes through more than one point? Yes, I can. Alright, it passes through 3 points. So no, this is not a function. Alright, this input, whatever this x value is, has 3 outputs on that graph. Alright, definitely not a function. Second thing on today's quiz is slope, your average rate of change. Alright, the slope formula, m, remember m is the letter that represents slope, is change in y over your change in x. And we write slope as a fraction. It's a ratio. Alright, let's keep it as a fraction unless told otherwise. Now the first way we calculated slope this week was from a graph. Alright, you drew a triangle, you chose 2 nice points, you drew a triangle, you counted your change in y and your change in x, and then you plug them into your slope formula. Alright, and I'll do an example with you right now. Alright, so here I have a graph. Alright, now this looks like a negative slope because it's falling from left to right. So remember, negative slopes fall, positive slopes rise. Alright, we pick 2 nice points that have whole numbers for their coordinates. These 2 points look pretty good. And then we're going to draw a right triangle that connects those 2 points. Alright, so I'm going to go down 2, right 1. Alright, I always start with my leftmost point when doing this. So I go down 2, so I write minus 2. And then I have to go right 1, which is plus 1. Alright, so my delta x is plus 1. My delta y is minus 2. So slope equals delta y over delta x. Change in y over change in x. So we have negative 2 all over 1. So the slope in this case is just negative 2. You could write it, keep it as negative 2 over 1, or just write it as a whole number, negative 2. Alright, so that's slope from a line. Alright, the other scenario we dealt with was slope from 2 points. So if I give you 2 points, like 4, 10, and 6, negative 2, and say that a line passes between them, calculate the slope or the average rate of change. Alright, I gave you 2 strategies for this. Alright, the easier one that most of you preferred was the table strategy, so that's what we'll stick with. We create an x and y table, alright, for our points. So we have our x values, which are 4, and that corresponds to an output or y value of 10. Then we have an x value of 6, which corresponds to negative 2. Alright, so fill in your table. Next, we have to calculate our change in y and change in x. So we draw arrows. How do you go from 10 to negative 2? Well, we're going to subtract 12. How do we go from 4 to 6? Well, we have to add 2. Make sure when you're doing this, your arrows are going in the same direction. Alright, now slope is change in y over change in x. Alright, you might also hear rise over run. So we have negative 12 over 2. And that simplifies to negative 6. All right, so the average rate of change for that line is -6. All right, if you can envision that, that's a negative slope, which is falling. Then the third thing that we dealt with this week was slope-intercept form. Y equals mx plus b. All right, these equations are used to model a linear relationship or a line. All right, it could be used to model the growth of somebody's money, I don't know, your batting average, all sorts of stuff in the real world. All right, so if you get an equation like y equals -2x plus 6, this is in slope-intercept form. All right, the number attached to the x is your slope. So the slope for this line is -2. The y-intercept is the number being added or subtracted. All right, that's your b value. So the y-intercept in this case is 6. All right, so if you can envision this, this is a line with a negative slope of 2, a y-intercept of 6. All right, and we'll get more into graphing next week. The second equation, y equals 8x minus 3. This is in slope-intercept form. Y equals m times x plus b. In this case, our m is 8, our slope. The y-intercept is -3, because that minus sign is really a negative attached to that number. So it crosses the y-axis at -3. All right, so that should get you a pretty good start on your quiz for today. All right, email me if you have any questions.